Hey there guys, welcome to my walkthrough of AQA's Level 2 Certificate in Further Maths Specimen Paper 2. Now this is specifically for the new spec for first exams in 2020, but if you're watching this in 2019, it's still very relevant for your revision. Any useful links that I have for topics I will put down below in the description. This stuff is pretty much AS level maths and I've got plenty of content on that. I will also link paper 1 down there and anything else that I think of that could be useful. So this is a calculator paper, so let's go. Okay, question 1. A sketch of the line y equals 2x and the line y equals 6 is shown. And we got these 3 points O, P and Q. Now it's not a very good sketch. The diagonal line is y equals 2x. Y equals 2x crosses both axes at 0, 0. So this point here should be 0, 0. Suppose they get away with that because it's only a sketch. Now our mission is to work out the area of triangle OPQ. So, to work out the area of a triangle, we need to know the height and base. So, we know that the horizontal line is y equals 6. So we know the coordinates of P are 0, 6. Now Q is going to have the same y coordinate. How do we find though the x coordinate? Well, these equations are simultaneous at points where they meet. So at this point, the x and y coordinates are equal for y equals 2x and y equals 6. So, we know that y is equal to 2x, and we know y is equal to 6. So if we substitute y equals 6 into y equals 2x, we get 6 is equal to 2x. So x is equal to 3. So we now know that essentially the base of the triangle is 3. The height of the triangle is 6. Area of a triangle is base times height divided by 2. So the area is 3 times 6 over 2, which is 9. Question 2. A circle centered at 0, 0 has circumference 20 pi. We want to work out the equation of the circle. So, circles centered at 0, 0 are of the form x squared plus y squared is equal to the radius squared. So we need to track down the radius. Now, the radius is half of the diameter. Circumference of a circle is pi times diameter. So here then we know that 20 pi is equal to pi times the diameter. So the diameter is equal to 20. So the radius is equal to 10. So the equation of the circle is x squared plus y squared is equal to 10 squared, so 100. Cool. Okay, question 3, we are told M is the midpoint of the line AB. Now we know the coordinates of point A are -2, 3. M is P minus 1 and B is 7, R. Now we want to work out the coordinates, or the values, sorry, of P and R. So, midpoint coordinates are the mean of the coordinates at the two ends. So, if we call the coordinates at A, x1, y1, and the coordinates down at B, x2, y2, then the coordinates of M are x1 add x2 over 2, y1 add y2 over 2. So if we apply that, let's first of all look at the x coordinates. So the x coordinate at A is -2, and the x coordinate at B is 7. So we know -2 add 7 over 2 is equal to P. -2 add 7 is 5, so P is 5 over 2, 5 halves. Now, R, well, this time we know that 3 add R over 2 is equal to the y coordinate at M, so that's equal to -1. Now we want to solve this for R. So multiply through by 2, we get 3 add R is equal to -2. Take away the 3, R is -5. Cool. 4a wants us to circle the solution to -3x is less than -18. Okay, so we have to be really careful with negatives when we're playing with inequalities. So we do here have a common factor of -3 on both sides. So we could divide through by both sides of -3. Now, if we do that on the left, we will get x, and on the right, we will get 6. Now, if you divide an inequality through by a negative number, or multiply through by a negative number, the direction of the sign changes. So we'd actually get x is greater than 6. So another way to think about that is, let's add 3x to both sides first. So we would get 0 is less than 3x minus 18. Then add the 18 to both sides, we get 18 is less than x. No, we don't. We get 18 is less than 3x. Divide through by 3, and we get x is greater than 6 again. Cool. And for part B, we want to solve x squared is greater than or equal to 16. So, again, be a little bit careful, it's a quadratic inequality. So, let's first of all think about the equation x squared is equal to 16. Now if we square root, we get x is equal to plus or minus 4. So if x is 4, x squared is 16. If x is greater than 4, x squared is going to be greater than 16. So one of our solutions is x is greater than or equal to 4. Now, if x is equal to minus 4, x squared is equal to 16. If x is less than minus 4, say something like minus 5, x squared is going to be greater than 16. So the other solution is x is less than or equal to minus 4. So, this is the guy that we want. Cool. Okay, question 5, we have a sketch of y equals f of x, where f of x is a quadratic function. We're told the graph intersects the x-axis at a, which is minus 1, 0, and b, and has a maximum point at 0.56. So the maximum is this point here. Cool. And A has coordinates minus 1, 0. So let's put those on 2. Okay, part A wants us to work out the coordinates of B. So, given that B is on the x-axis, the y-coordinate is 0. How do we work out the x-coordinate? Well, quadratics are symmetrical. Now, we know the x-coordinate slap bang in the middle of A and B is 0.5. Now, to get from minus 1 to 0.5, we've gone along by 1.5. So to get over to B, we're going to go along another 1.5, which is going to give us 2. So the coordinates of B are 2, 0. Okay, and then part B tells us the equation f of x equals k has exactly one solution. We want to work out the value of k. So f of x equals k is going to be a horizontal line. So if there is only one solution, then we only want this line to hit the curve at exactly 1 point. So if I attempt to draw a horizontal line like that, if this line was anywhere down here, then it's going to intersect the quadratic at 2 points. So there would be 2 solutions. We only want it to hit the quadratic at 1 point. Now it's going to do that at the maximum. So that line is y equals 6. So the value of k is 6. Okay, question 6. So we've got two matrices and two vectors. We got these constants s, t and u kicking around in them. For part A, we are told that a, b is equal to c. And we want to work out the values of s and t. So let's work out a, b first of all. So a, b is 4 minus 1 minus 7, 2 times s minus 5. Right, so when you multiply them, a matrix by a vector, what's going to happen is we're going to get 4s minus 1 times minus 5 that's what we're going to get on the top, and then on the bottom we're going to get minus 7s minus 5 times 2. So that's going to give us 4s add 5, and then on the bottom minus 7s minus 10. Now we know that that is equal to c, so c is minus 1t. Okay, so we know then, first of all, that 4s add 5 is equal to minus 1. So we can solve that for s. So take away the 5, 4s is minus 6, divide by 4, s is minus 6 divided by 4, which is minus 1.5. Okay, so now we can work out the value of t. So we know that minus 7s, so minus 7 times minus 1.5, minus 10 is equal to t. Now, minus 7.5, minus 7 times minus 1.5 is positive 10.5. So 10.5 minus 10 is equal to t. Therefore, t is equal to 0.5. So s was minus 1.5. T is 0.5. Cool. Okay, then part B tells us that AD is equal to I, the identity matrix. And now our mission is to find the value of U. So, A is 4 minus 1 minus 7, 2. And D is 217U. Now the identity matrix is 1, 0, 0, 1. Okay, now this is only one mark, so we wouldn't necessarily need to do the full multiplication. We could just work out one part that contains U, set that equal to the corresponding part of the identity matrix, and then solve for U. It's good practice though, so I'm going to do the full multiplication. So, the top left element is going to be 2 times 4 add 7 times minus 1. The top right element is going to be 1 times 4 add U times minus 1. So that's going to be minus U bottom left element is going to be 2 times minus 7 add 7 times 2, and then the bottom right element is 1 times minus 7 and then add U times 2. So, 2U. Okay, so let's clear this up a bit. So, up the top right, 2 times 4 is 8, add 7 times minus 1 is minus 7, so that is indeed 1. Top right, 1 times 4 minus U is 4 minus U. Bottom left, 2 times minus 7, add 7 times 2 is 0. And then bottom right, 1 times minus 7 is minus 7, add 2U. Now we know that is equal to 1, 0, 0, 1. So we could say that 4 minus U is equal to 0. Therefore, U is equal to 4. Now we can also check that. Is that going to give us the 1 that we need on the bottom right? Minus 7 add 2 times 4 is minus 7 add 8, which is 1. Job done. Okay, question 7. We want to work out the equation of the line that is parallel to 2y equals x and intersects the x-axis at 4, 0. So, if 2y is equal to x, then y is equal to x over 2 or 1/2 x. So we know then that m is equal to 1/2. If we then substitute that into y equals mx plus c, we know y is equal to 1/2 x plus c. Now we also know that when x is 4, y is equal to 0. So when x is 4, y is equal to 0. If we substitute those values into our equation above, we get 0 is equal to 1/2 times 4, which is 2, add c. So c is equal to minus 2. The equation of our line is y equals 1/2 x minus 2. Cool. Question 8a wants us to work out AB over CD divided by BC over AD, giving our answer as a single fraction in its simplest form. So, when you divide by a fraction, you flip it over and times by it. So we've got AB over CD times AD over BC. So up on top, AB times AD is A squared BD, and on the bottom we get BC squared D. Now we can cancel out quite a few things. So up on top we got the A squared. Now the B on top cancels with the B on the bottom, and the D on top cancels with the D on the bottom. So we've actually just got A squared over C squared. Okay, then for part B, similar sort of thing, we want to work out 7 over 2x squared and 4 over 3x as a single fraction in its simplest form. So, there are a few ways that we can do this. If you know the picnic table method, cool, that's the way that I would use. If not, probably go common denominators. So, the first thing that 2 and 3 both go into is 6. And the first thing that x squared and x go into is x squared. So we're going to make it so that each fraction has 6x squared on the bottom. So 7 over 2x squared needs us to multiply the top and bottom by 3. So we get 21 over 6x squared. 4 over 3x needs us to multiply 3x by 2x. So we have to do that on top as well. So that's going to give us 8x on top and 6x squared on the bottom. So we've now got 21 over 6x squared, add 8x over 6x squared, which is going to give us 21 add 8x over 6x squared. We can't simplify that at all, so job done. Okay, question 9, we have a nice circle theorem problem here. So A, B and C are points on the circumference of a circle. Now we got a few angles algebraically. So we know this angle in the centre is x and 62. The angle up here is 2x minus 50. And we've also got down here angle y. Now our mission is to work out the size of angle y. Okay, so first of all, using one of our circle theorems, when you have like an arrowhead, which we have here, the angle at the circumference is half the angle at the centre. So, 2x minus 50 is half of x add 62. So we can say that's half x add 62. What this is going to allow us to do is work out what x is. So if we multiply both sides by 2, then we get 4x minus 100 is equal to x add 62. Now if we take away x, we get 3x minus 100 is 62. Add the 100, we get 3x is 162. Divide by 3, and we get x is 54. So now that we know what x is, we can start filling in some blanks. So if x is 54, x add 62 is 54 add 62, which is 116 degrees. So that is this angle here, 116 degrees. Now, we also know that this point O is the centre of the circle. That means that this line and this line are both a radius of the circle, so they are equal in length. Now that also means that this angle here is y degrees 2. So angles in a triangle add up to 180. So 2y add 116 is equal to 180. Take the 116 away. 2y is a number like 64. And then divide by 2, y is 32 degrees. Cool. Okay, question 10. Y is 6x to the power 9 and x to the power 8 over 2x to the power 4. We want to find the value of d squared y over dx squared when x is equal to 0.5. So this is differentiation, if you want any more content on this, check out my playlist down below. D squared y over dx squared is the second derivative, so we need to differentiate this twice. Before we do that though, we can simplify the fraction, so let's do that. There is a common factor of x to the power of 4 here, so we can divide everything through by x to the power 4. So if we do that, we get 6x to the 5 add x to the 4 all over 2. Now we can even split that up into 6x to the 5 over 2 add x to the 4 over 2. Now 6x to the 5 over 2 is just 3x to the 5. So we can say that y is 3x to the 5 add x to the 4 over 2. Alright, so now we can differentiate. So dy by dx. Okay, so the 5 comes down and multiplies to 3, which gives us 15x. Now the power goes down by 1. So the power is now 4. Okay, and then the second term, the 4 comes down, so we're going to get 4 over 2, which is 2. X. Now the power goes down by 1, so it's 3. So that's our first derivative. Our second derivative, well, the 4 comes down and multiplies to 15, so we get 60x cubed, and then add, the 3 comes down and multiplies to 2, so we get 6x squared. Okay, so now we want to substitute in x equals 0.5. So we're going to get 60 times 0.5 squared, cubed. Now you can of course do this with your calculators. I'm going to try and do it in my head though. So 1/2 to the power of 3 is 1/8. And then add 6 times 1/2 squared, which is 1/4. So 60 over 8 is 30 over 4, is 15 over 2, so that's 7.5, add 1.5, we should get 9. Cool. Okay, question 11, we got some sequences. So, for sequence A, the nth term is n over 14n and 30, and for sequence B, the nth term is 2 over n. We are told the kth term of sequence A equals the kth term of sequence B. We want to find the value of k. We must show our working. So, what this means then is that when n is equal to k, then the term in sequence A is equal to the term in sequence B. So, in other words then, we get k over 14k add 30 is equal to 2 over k. Now we want to solve that for k. Okay, so we don't want fractions, so let's first of all multiply through by 14k add 30. Then we're going to get k is equal to 2 lots of 14k add 30 all over k. Let's now multiply through by k. So we get k squared is equal to 2 lots 14k add 30. Let's now expand the brackets. K squared is equal to 28k add 60. Now this is quadratic, so we want everything on the same side. So we're going to take away 28k. So we get k squared minus 28k. And we're also going to take away 60. So minus 60. That is equal to 0. Now, can we factorise this? Be nice if we could. So numbers that multiply together to 60 are 1 and 60, 2 and 30. Bingo. 2 and 30 have a difference of 28. So, given that we have minus 28, we're going to want k minus 30 times k plus 2. Now that's going to give us two possible solutions for k. K is 30 or k is minus 2. But remember, k is the number of a term in a sequence. So k cannot be negative. So this solution makes no sense. K is equal to 30. Go. Question 12. We have a ship made from two rectangles. All dimensions are in centimetres. We are told the perimeter of the shape is 252 centimetres. We want to show that y is 126 minus 45x. So what we need to do is get an algebraic expression for the perimeter. So we have all of the lengths except one, and that is the left hand side. Now we know that's going to be the same as the vertical lengths on the right. So on the right we have y and 15x. So this length here is y add 15x. Okay, so let's go around and add all of the x's together. So we got 15x over here, we got 30x, so that's 45x, we got another 15, so that's 60. 10 makes it 70. And then we have another 20 on the bottom, that makes it 90x. So the perimeter is 90x. And then let's add the y's. So we got a y on the left, and then this one y down here. So we know then that 90x add 2y is equal to the perimeter, which is 252. If we take away the 90x, 2y is 252 minus 90x. And if we divide by 2, y is 126 minus 45x. Cool. Okay, part B tells us the area of the shape is a centimetre squared. We want to show that a is 2520x minus 450x squared. Okay, so let's split this shape into two rectangles. Now I'm going to go across like that. Now we know the area of this bottom part is 20x y, and the top part is 15x times 30x. 15 times 30 is 450, so we get 450x squared. Okay, so up to here, a is 20x y add 450x squared. Now we want the area to be completely in terms of x, so what we're going to do is make the substitution that y is 126 minus 45x. So we're going to get a is 20x times 126 minus 45x add 450x squared. So 20x times 126 is 2520x. 20x times minus 45x is going to give us minus 900x squared, and then we got that plus 450x squared. So this does indeed simplify to 2520x minus 450x squared. Okay, part C wants us to use differentiation to work out the maximum value of a as x varies. So, a maximum is a type of stationary point. At stationary points, the gradient of a curve is equal to 0. So we need to find dy by dx, set that equal to 0, and then solve for x. So a is 2520 x minus 450 x squared. Now if we differentiate this with respect to x, dA by dx, well, 2520 times x just becomes 2520. So what happens there, the x has a power of 1, that comes down and multiplies the term, and then the power goes down to 0. X to the power 0 is 1. And then the second term, the power of 2 comes down and multiplies the 450. So we get minus 900. And the power just goes down to 1. So we get minus 900 x. Now if we set that equal to 0, add the 900x, and then divide by 900, we get that x is equal to 2.8. So to find the maximum area, we now substitute x equals 2.8 into our expression for A. So when x is 2.8, A is 2520 times 2.8 minus 450 times 2.8 squared. Now that should give us 3,528 centimetre squared. Cool. Question 13, we have functions, so I'll put my function stuff down below in the description. F of x is 3x squared, add 6 for all x. G of x is root x minus 5 for x greater than or equal to 5. We want to find the value of f g of 4. No, we don't. G f of 4. So g f of 4 means g of f of 4. So if we first of all find f of 4, well, we get 3 times 4 squared, add 6. 4 squared is 16. 3 times 16 is 48. 48 add 6 is 54. So our question now, g of f of 4 is g of 54. So we substitute x equals 54 into g of x. So for that, we're going to get root 54 minus 5 which is root 49. So technically that's positive or negative 7. It does only say though the value, so you'd probably be fine just with 7. Part B wants us to show that f g of x can be written in the form a times x minus a, where a is an integer. So f g of x means f of g of x. So this means f of root x minus 5. So the x in f of x becomes root x minus 5. So the f function was 3x squared and 6. So this then is going to be 3 lots of, well, it's x squared, but x is now root x minus 5. Squared add 6. Now, if you square a square root, the two things cancel out. So we've got 3 lots of x minus 5 add 6. Expand the brackets, we get 3x minus 15 add 6. So we can factorise. Let's simplify first though, so we get 3x minus 15 add 6 is minus 9. Now we can factorise. So we get 3 lots of x minus 3. Cool. Question 14. We've got a non-right angled triangle and we're told to use the sine rule to work out the obtuse angle x. So there is a key word there, obtuse. X has to be obtuse, greater than 90. Okay, by the sine rule then, sine of x over 2y is equal to sine of 18 over y. Now, both fractions here have a y on the bottom, so we can multiply through by y and they will disappear. So we get sine of x over 2 is equal to sine of 18. We then want to get sine of x on its own, multiply through by 2. Sine of x is 2 sine 18. Now we need to get x out of the sine function, so we're now going to inverse sine both sides. So x is the inverse sine of 2 sine of 18. So that will give us x equals 38.2 degrees. But there's a problem. That is not obtuse. So now we need to find another solution. So sine of x looks like this. Now what we've just got here is this solution of 38.2 degrees, but it's not obtuse. So if we carry this line across, we get another solution over here. Now this point is 180 degrees. Now, using the symmetry of the graph, that second solution is the same distance back from 180 as the first solution is away from 0. So to get this next solution, we do 180 minus 38.2, and that gives us 141.8. So that would be the guy that we want. Cool. Okay, question 15. We have a sketch of the curve y equals ab to the minus x, where a and b are positive constants. We're given 2 points that lie on the line 0, 3 and 2, 0.48, and our job is to work out the value of a and b. Okay, so we're going to do that by using the 2 points that lie on the curve. So, at this point, we know that when x is 0, y is 3. So, when x is 0, y is 3, that gives us 3 is equal to a b to the power 0. Any number to the power of 0 is 1. So this then tells us 3 is equal to a. A is equal to 3. So now we know the equation is y equals 3b to the minus x. Now if we go to the other point, we know when x is 2, y is 0.48. So, when x is 2, y is 0.48. So, substitute those in, we get 0.48 is equal to 3b to the minus 2. Now, b to the minus 2 means 1 over b squared. So 3b to the minus 2 is 3 over b squared. So 0.48 is 3 over b squared. If we multiply through by b squared, 0.48 b squared is equal to 3. Divide by 0.48, and we get b squared is 6.25. So then if we square root, b is 2.5. So a was 3, b is 2.5. Okay, question 16, algebraic fraction fun. So I'll put my stuff on this down below. We want to simplify 8x cubed minus 50x over 2x times 6x squared minus x minus 35, giving our answer in the form ax plus b over cx plus d, where a, b, c and d are integers. Okay, so the trick to simplifying something like this is to first of all factorize. So let's just look at the top. There's a common factor of 2 we might spot first of all. So we can take 2 out. That's going to give us 4x cubed minus 25x. Now there's still a common factor in there. Let's go down here though, where we have more room. The other common factor is x. So if we also take an x out the front, then we've got 2x times 4x squared minus 25. Now on the bottom we have 2x times 6x squared minus x minus 35. So at this point we now have a common factor on the top and bottom of 2x. So they cancel with each other. So we're left with 4x squared minus 25 over 6x squared minus x minus 35. So now we got 2 quadratics on the top and bottom. The top is a difference of 2 squares. The first term is a square number, second term is a square number, there's a subtraction in the middle. So this factorizes to 2x plus 5 times 2x minus 5. Now that allows us to cheat a little bit on the bottom. We know that we are able to write this fraction with a linear expression on top and a linear expression on the bottom. That means then one of the brackets on the bottom has to have a 2x and a 5 in it. Now to get a 6x squared, we know that we're going to need a 3x, and then to get a 35, we're going to need a 7. Now one of those is going to have to be positive and one negative. So if we had positive 5x, we get positive 5 in the first bracket. 5 times 3x is 15x. And then we'd have minus 7 times 2x, which would leave us with a positive x in the middle. But we want a negative x. So it's going to have to be minus 5 in there. So minus 5 times 3x gives us minus 15x. And then if we put a plus in there, 7 times 2x gives us plus 14x. So minus 15x, add 14x, does indeed give us that negative 1x that we need. So now, on top and bottom, we have a common factor of 2x minus 5. So they cancel out, and we get left with 2x, add 5 over 3x, add 7. Cool. Okay, question 17. By multiplying both sides of the equation by x to the power of 1/2, we want to solve 2x to the power 3/2 minus 3x to the 1/2 equals 7x to the minus 1/2 for x greater than 0. Giving our answer to 3 sig figs, we must show our working. So, if we multiply through then by x to the power of 1/2, we get 2x to the 3/2 times x to the 1/2 minus 3x to the 1/2 times x to the 1/2 equals 7x to the minus 1/2 times x to the 1/2. So, when you're multiplying the same base number, you add the powers. So, x to the 3/2 times x to the 1/2 is x to the 4/2. 4/2 is 2. So we got 2x squared. Now, x to the 1/2 times x to the 1/2 is x to the power 1. So we got minus 3x. And then on the right, 7, x to the minus 1/2 times x to the 1/2 is x to the minus 1/2 plus 1/2, which is x to the power 0. So on the right, we've just got 7. So at this point, it's now a quadratic equation. To solve these, we need everything on the same side and a 0 on the other. So let's take away the 7. So 2x squared minus 3x minus 7 is equal to 0. Now this is a pretty horrible looking quadratic. There is a clue in the question as to what we need to do now. It said give our answer to 3 sig figs. That's basically telling us this can't be factorised, so use the quadratic formula, which is x equals minus b plus or minus root b squared minus 4ac all over 2a. So for us, a is 2, b is minus 3, c is minus 7. So we get x is minus 3, it's positive 3, plus or minus 3 squared is 9. Now, minus 4 times 2 is minus 8, times minus 7 is positive 56. And then 2a, 2 times 2, which is 4. So, x is 3 plus or minus root 65 all over 4. Now, at this point, remember that the question said solve for x greater than 0. If we did 3 minus root 65, that would give us a negative number. Root 65 is just bigger than 8. 3 minus 8 is negative, so 3 minus something bigger than 8 is going to be even more so. So we only actually need to worry about x is 3 plus root 65 over 4, which to 3 sig figs will give us 2.77. Cool. Okay, question 18, bit of a fun one here. So, how many odd numbers greater than 30,000 can be formed using the digits 2, 4, 6, 7 and 8 with no repetition? So, let's think about this then. We need these numbers to be greater than 30,000. So the first digit has to be 4, 6, 7 or 8. For it to be greater than 30,000, but the last digit for the number to be odd has to be 7. So let's finish off that. I'm going to call the number n, but final digit has to be 7. For n to be odd. So, first digit can only be 4, 6 or 8. So, what we're going to do is work out how many numbers greater than 30,000 we can make with one of these digits in the first place. Work that out and then just multiply by 3 because it will be the same for the other starting digits. So, let's say that we put 4 first. And then we got 3 digits in the middle and 7 at the end. Now, we could have 2, 6, 8. We could have 2, 8, 6. We could have 6, 2, 8. We could have 6, 8, 2. We could have 8, 2, 6. And then we could have 8, 6, 2. So there are 6 combinations for each starting digit. So 6 combos per starting digit. So, for example, if we put 6 now as the starting digit, we would get another 6 possible numbers. So, altogether then, we can have 3 starting digits. 3 times 6 is 18. Cool. Okay, 19. F of x is 3x cubed minus 2x squared minus 7x minus 2. Part A wants us to use the fact theorem to show that 3x plus 1 is a factor of f of x. So, I have plenty of fact theorem content. It's in my polynomials playlist down below. So, if 3x add 1 is a factor, then, well, essentially what we're doing, we set 3x plus 1 equal to 0 and solve for x. So 3x is minus 1, so x is minus a third. So, by the fact theorem, if 3x plus 1 is a factor, then f of minus 1/3 will equal 0. So, let's try it. So, 3 lots of minus a third cubed. Well, we got 3 lots. So we got 3 lots of minus a third cubed is minus 1/27. Remember, this is a calculator paper. Minus 2 lots minus a third squared is positive 1/9. Minus 7 times minus 1/3 is add 7/3, and then we got minus 2 at the end. So, if you stick that in your calculator, you will indeed get 0. So, 3x add 1 is a factor. Cool. Part B wants us to factorise f of x fully. So, at the moment, we know that f of x is 3x plus 1. Now, it's a cubic polynomial, so it's going to have 3 linear factors, or at least it should do, because this is GCSE. It might be cubics can just have 1 linear factor and a quadratic factor. Let's see if we can find any other linear ones using the factor theorem. So, let's try f of 1. So, f of 1 is going to be 3 times 1, so 3 minus 2, which is 1, minus 7, which is minus 6, minus 2, which is minus 8. So, f of 1 is minus 8. So, x minus 1 isn't a factor. Let's try f of minus 1. So, minus 1 cubed is minus 1, so 3 times minus 1 is minus 3. Minus 1 squared is 1. So we got minus 3 minus 2. So up to there, that's minus 5. And minus 7 times minus 1 is positive 7. So minus 5 add 7 is 2. And a minus 2 on the end, we do get 0. So f of minus 1 is equal to 0. That means x plus 1 is a factor. Now that we know 2 factors, we can work out the last one. So f of x is 3x add 1 times x add 1. Now to work out the final factor, well, we know that f of x has a 3x cubed, so we're just going to need an x there. Now at the end of f of x, we have a minus 2. That number comes from multiplying the 3 numbers in the brackets together. So at the moment, the numbers at the end of each bracket. So at the moment we got 1 times 1, which is 1. We need 3 numbers to multiply together to minus 2. So the final bracket is going to have to be x minus 2. So then 1 times minus 2 is minus 2. Cool. Okay, question 20. VABCD is a pyramid with a horizontal rectangular base. VA equals VB equals VC equals VD, which equals 10 centimeters. So those are the lengths from the tip down the sides. So this is 10 centimeters. We're also told AB is 8 and BC is 6 centimeters. So let's put those on. AB is 8. BC is 6. We are told, I missed that bit. V is directly above the centre of the base, and M is the midpoint of BC. So, we want to work out the size of angle VMD. So, this angle here. Okay, so if we think of VMD as a triangle, then let's build that out and make a sketch. So there's V, there's M, and there's D. Now, this is going to be non-right angled, so it's not circular. Let's think. We can work out the length VM. So if we make a little sketch here, so this is one of the faces of the pyramid. So if we got V top there, M in the middle there, then we know the slant is 10, and we know that M is the midpoint of BC. So, the length MC is 3. So, by Pythagoras, VM squared is 10 squared minus 3 squared, which is 91. So V to M is root 91. So there's one length. Can we work out either of the other two? Well, we know that VD is 10. So, can we work out the third? If we can, then we can use the cosine rule to work out the angle. So, the other triangle that we've got going on is DCM. So if we make a sketch of that, so there's D, C, and M. Now we know that CM is 3. We know CD is the same as AB, which is 8. So again, using Pythagoras, DM squared is 8 squared add 3 squared, so 73. So, DM is root 73. Okay, so now we are in a non-right angled triangle where we know 3 side lengths. So we can work out any of these angles using the cosine rule. So it's this angle here that we want. So let's call this angle A. That makes this side A, and then B and C. Now the cosine rule is this guy, A squared B squared plus C squared minus 2BC cos of A. So we're going to get 10 squared, which is 100, is equal to B squared. So root 91 squared is 91. Add root 73 squared, so that's add 73. Minus 2 root 91 root 73 cos of A. So 91 add 73 is 164. So if we take that away from both sides, we go minus 64 is 2. No, it's not. It's minus 2 root 91 root 73 cos of A. Now if we divide through by minus 2 root 91 root 73, we get 32 over root 91 root 73 is equal to cos of A. So A is the inverse cos of 32 over root 91 root 73, which gives us 66.9 degrees to 1 decimal place. Lovely. Okay, the final question, algebraic proof. We want to show that 2n plus 3 cubed and n cubed is divisible by 9 for all integer values of n. So, I think you guys will learn binomial expansion. So, if so, you can use that to expand the brackets, but just in case, let's do it old school. So, 2n plus 3 times 2n plus 3 is 4n squared, add 12n, add 9. So then we need to do 4n squared, add 12n, add 9 times 2n, add 3. Now a nice way to do this is using a table. So, across the top, 4n squared, 12n, and the 9 down the side, 2n, and 3. So 2n times 4n squared is 8n cubed. 3 times 4n squared is 12n squared. 2n times 12n is 24n squared. 3 times 12n is 36n. 2n times 9 is 18n. And 3 times 9 is 27. So, 2n plus 3 cubed is 8n cubed. Then we got 12 and 24 n squared. So that's 36n squared. We got 36 and 18n, so that's 54n. Then we got a plus 27 at the end. So that's what we get when we expand 2n plus 3 cubed. So, 2n plus 3 cubed add n cubed is 9n cubed, add 36n squared, add 54n, add 27. Now, how can we show then that this is always divisible by 9 for integer values of n? Well, we factorise. So we do here have a common factor of 9. So we can write this as 9 times n cubed, add 4n squared, add 6n, add 3. So we can finish by saying 2n add 3 cubed add n cubed has common factor of 9, or actually we can say slightly better, 2n plus 3 cubed add n cubed is a multiple of 9. So can always be divided by 9 when n is integer. Cool. Okay guys, there's the paper done. Hope you found this useful. If you're watching this in 2019, good luck for your exams. If you're watching this sometime in the future, good luck with your exams. Hopefully I've done more work by now to help you with your exams. Take it easy guys. Take care.